Hello, my name is Alexey Matveev, and in this video we will talk about CSRF attacks in Atlassian on-prem applications. Okay, let's start. What are the contents of the presentation? First of all, we will talk about a WASP, and then we will talk about what is a CSRF attack. We will see how to prevent CSRF attacks for general purpose, not only for Atlassian. Then we will talk about how to prevent CSRF attacks in Atlassian on-prem apps. And then we'll talk about bug bounty program. Okay, let's start. Let's start with a WASP. What is a WASP? A WASP is a non-profit foundation that works to improve the security of software. A WASP has a website in the internet, you can find it, and there you can find lots of information on how to prevent all kinds of security attacks. The most famous thing about a WASP is the WASP top 10 list. This list is refreshed periodically. For example, the latest one was created in 2017, and before it was 2013, and so I guess we're waiting for the new list maybe in 2021 or sometime later. If we have a look at the WASP top 10 list for 2017, we will see that we do not have the CSRF attacks. But CSRF attacks were present in 2017 list. Why? The reason is because CSRF attacks are known how to prevent, and most frameworks contain already built-in capabilities for preventing CSRF attacks. But it's not the case for Atlassian products, Atlassian on-prem products, Data Server and Server. That is why when you create an Atlassian on-prem application, you need to take care about CSRF attacks. What is a CSRF attack? Okay, let's have a look. CSRF attack is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. For example, let's say you authenticated into Jira, and then in Jira you've got a servlet which saves some kind of parameter in Jira. And then on some other site, you opened it while you were authorized you're now authenticated into Jira. You opened another site, and then the site contains some kind of HTML which saves data in using your servlet in Jira. And then the site will be able to do it. Why? Let's have a look at the example. Let's say I'm authenticated into Jira. Here it is. And then, as you can see, I've got their servlet, CSRF servlet. And then if I push the save button, the value parameter 1 will be set for the parameter 1. Why? Because first of all, when I push the save button, a request is executed. It's a post request to my servlet. The other thing, as you can see, cookies are sent. So JS session ID is sent to Jira, and Jira knows that I'm authenticated into Jira. And that is why when I pass the value for the parameter, the value will be saved, because Jira knows I'm authenticated. And that's a valid path, because as you can see, I pushed the save button from the localhost 9990. That is where my Jira is. But what can an attacker do about it? Attacker can create a simple HTML, which would look like this. As you can see, it's a form, and it contains a button of submit type, and then it's got an action. Basically, this action performs a post request to my servlet and passes the value for parameter 1. Okay, let's try to execute it. This HTML can be embedded into the attacker's website, or for example, in my case, I will just load a file, and then I will try to push this submit button and see what will happen. Okay, I opened my file in the browser where I already authenticated into Jira. And then the next thing, I'm pushing the submit request. You can see that a request was sent to Jira. Also, all cookies were sent to Jira as well, even if I pushed this button not from the Jira itself, but from another file, or even if I do the same from another web server, all cookies still will be sent for my resource, because that's how the browser works. And as the result, Jira knows that I'm already authenticated and that everything is valid, and then I also pass my parameter, and that's it. Jira thinks I'm authenticated, then it saves the value first, and then it redirects me to my servlet. And as you can see, I'm authenticated into Jira, and the value for the parameter is changed. And that is how CSRF attacks work. So what we can do about preventing CSRF attacks? In this presentation, I will talk only about stateful applications because means to prevent CSRF attacks for stateful applications and stateless applications are different. But Atlassian applications are stateful applications. That's why we are talking only about stateful applications, how to prevent CSRF attacks in stateful applications. The first known way to prevent this attack is synchronize the token pattern. This one generates a CSRF token on the server side and uses this token to verify if the client is permitted to execute the request. The second one is same site cookie attribute, and the third one is verifying origin with standard headers. Okay, let's talk about each of them. Same site cookie attribute. That's basically a cookie attribute which helps the browser to decide whether to send cookies along with cross-site request or not. Possible are lax, strict, and none. It looks like this. So for example, when you create a cookie, you add an attribute called same site and you equal it to some value. If the value will be strict, it means that cookies will not be sent if you if you do a post request from a site to which this post request does not belong. So in my case, if I want to make a request to a servlet on my domain, I can do it only from a page which I open from this domain. In my case, localhost 2990. But if I execute this request from an attacker website, cookies will not be sent. And as the result, Jira will not be able to authenticate me, and then nothing will be saved. That's how it works. Lax, it's the same behavior as default, like we saw before, cookies will be sent. And there is also another option, none. None even is more relaxed than lax. It lets you embed, for example, images from from your resource, and again cookies will be sent, you will be authenticated, and for example, if an image can be received only if you are authenticated, you will still receive this image. If you don't use none, you will not be able to see the image. That's how it works. And I think it's a good thing, but the problem is that there are two known ways how to bypass the strict mode. That's why OWASP doesn't recommend to use this same site cookie attribute as the only mean to prevent CSRF attacks. You should use other means. But the idea is very good because you can pass several cookies, one with strict and another one with lax. And then, for example, if you are executing a request from the same domain, you will get the strict cookie, and then you know that the request came from the same domain, and for example, you can save the value or do many different operations. But if, for example, you received a lax cookie, it means that your request was executed from another domain. But maybe still you don't want, for example, users to save data, but maybe you want to let users browse data. That's why, for example, they will be able to browse the data they want. It's a good way to limit user permissions, but it cannot be the only way to prevent CSRF attacks. Another one is verifying origin. Browsers automatically pass the origin and refer headers with the request, and the browsers put the domain or the path from which the request was called. And analyzing this domain or path, you can decide if the request came from the valid destination or from their own destination, and then you can forbid or permit actions in your program. The problem about it that origin and refer headers are included majority of times, but there are a few cases where they're not included. That's why I believe that the most reliable and simplest way to prevent CSRF attacks is synchronize the token pattern. Synchronize the token pattern consists of 4 main actions. The first one, you need to generate a token on the server. Then you need to send this token to the client, to the form which the client uses. Somehow it must be there. Then when the client pushes the save button, for example, or whatever actions the client performs, this token should be sent to the server. And then the server should verify the token which was received from the client and which the server has. And that's how it works. If the token is correct, then you can perform the action. If not, then the action will be refused. Now let's talk about each step in more details. A token is generated on server. It is generated once per session or per request. So, for example, let's say you generate a token once for request. It means that, for example, you open 2 tabs, then you will overwrite the token from the previous tab with the tab which you opened the last. Which means that, for example, if you want to push the save button from the previous tab, it will not work because the token is already not as it was before. And that is why it's a bit simpler to use session tokens, because session tokens are valid for the session of the user, not for requests. And if we use session tokens, so it means that each user has to have a unique session token. Also, the token must be secret and unpredictable. This is very important things which should you consider while creating tokens. Okay, how could we, for example, generate a token? For example, it can be this function called getToken. It's in Kotlin, but it doesn't actually matter. I chose Kotlin because Kotlin is more concise and it's easier to understand the code. Kotlin doesn't contain any inbuilt CSRF attack prevention or something like this, so just the code is short, that's all. Okay, so how to get the token? First of all, we get the request session because we are going to save our token for a session. Then we try to get the attribute. For example, our token is called ATL token. If the token is not found, then we need to generate it. In my case, I generated with random UUID. So it's random and it cannot be predicted. And then I set this ATL token as a session attribute and I return the token. That's it. That is how we can generate the token. Then we need to send the token to the client. Tokens can be sent by cookies, but tokens shouldn't be transmitted via cookies. And that's how WASP says it. By HTML, you can include it into a meta or input tag. It actually doesn't matter what to use, meta or input. Just, for example, if you use the form tag, it's simpler to put it into an input tag. And if you use JavaScript to execute a request, then it's easier to put into the meta tag. Also, you can put it into request headers as a custom request header. So the HTML and request headers are the valid paths. Now, the next thing, when you want to do the action, you push a button and then you need to transfer the token back to the client. So you can do it again with the cookies, but you should not do that. You can create a post request from the form tag as a parameter. That's exactly what I did when I showed you examples how to do a CSRF attack. Or again, you can use a custom request header. So the post request and request header are the valid paths here. And then the next thing, the server must verify the token. So here is the code. For example, What's in the code? We get a tail token from the parameter. In my case, I'm sending the token via parameter, not via a custom request header, but as a parameter. So I get that tail token. Then if that tail token is null, or for example, we don't have the token defined in our session, or the token in the parameter doesn't equal to the token in the session, then we just send an error to the client. If everything is fine, then we proceed with our code. That's how you can verify it. Okay, and the next part is how we can prevent CSRF attacks in Atlassian on-prem apps. As you can see here, I created a repository. Here is my repository. Here I created plugins for Bamboo, Bitbucket, Confluence, Fekru, and Jira. And this repository has two tags, V1 and V2. Tag V1 doesn't contain any CSRF prevention. It's actually everything is generated there by default. Tag 2 contains CSRF prevention. I'm right now have tag 2 here, and for example, if we have a look at Jira, we can see that we've got here a web work and a servlet. And then, for example, if you go to servlet, you will be able to see actually that the code which I provided you is an example. So it's how to prevent attacks. But let's continue with the presentation, and then we'll have a look at the code. Okay, so how we are going to prevent CSRF attacks in Atlassian on-prem? Atlassian by default supports CSRF token prevention. But still, it doesn't mean that if you created something by default, your applications will not be vulnerable to CSRF attacks. Your applications will be vulnerable, but Atlassian will be creating CSRF token by default. You can use the tokens if you want. And I've got this table. What this table says that, for example, if you create servlet, Xwork or WebWork by default, then you have no protection except of Bamboo. So if you created something out of the box, you have protection only for Xwork and only for Bamboo. Okay, so protection is not enabled by default. How you can implement it? First of all, you can use SAL solution. It's SAL API, and it means that this solution can be used for all plugins, and it will be. It means that you will have the same solution for everything. How to implement SAL solution? You need to use XSRF token accessor interface to get the XSRF token, and then XSRF token validated to validate form encoded token. That's what you have to do. I have an example in Bitbucket. Let's have a look at it. Let's open Bitbucket. For example, let's take our servlet. Here it is. And you see what's going on here. So when I get, when I do the get parameter, here it is. What I'm doing here, I'm getting that L token and put it into the context. XRF token accessor. That's how I get the token. And then this token gets into my VM template. And here I added an input field, which is called a tail token, and then I equal it to a tail token, to that tail token parameter. And then when I push the save button, the token is sent as a parameter, and then here I use XSRF token validator to validate the token, and that's it. So basically what I need to add, I need to get the token here, then I need to validate the token and add the token in the form.vm. That's all, and it works. So that's how you work with SAL solution. But also Atlassian provides different way to implement CSRF protection for different modules and applications. For example, Jira Web Work. If we've got a Jira Web Work, all we have to do, we have to add the requires XRF check attribute for the method which saves data, and then to add the input type hidden to VM or soy template. Let's have a look. Let's open Jira. Here is our web work, and here, as you can see, I added requires a XSRF check attribute, and also I added the input parameter to our form over here, and that's it. The web work will work. The web work will check the CSRF token. If we use Jira Servlet, then we can use XSRF token generator to generate a token. Then we need again to add this input type hidden into VM or soy template. And then we also need to validate the token. Okay, here is how it's done. I already showed you here. So again, I'm getting the tail token using this XSRF token generator. That is actually Jira class. Where is it? Here it is, you see. Then I made in a parameter over here. Here it is in my VM template. And then I validated using the code which I provided when we talked about protection in general. That's how you can do it in Jira Servlet. Or you can use, of course, SAL. In Confluence, we need to add form XSRF token to the VM soy template. It looks like this. I will show you. Let's open Confluence. Templates. That's how it looks like. So you need to add it just to your VM template or soy template. And that's it, basically. Your XWork will work. But if you have a look at the documentation for Atlassian, you also need to add this parameter, but I tested it on the latest versions of Confluence, and you don't need actually to provide this parameter. It will work without this parameter. Confluence Servlet, again, it's about the same as Jira. You can use simple XSRF token generated token, then add this input type field to the VM soy template, and then validate the token. That's it. You can use the code which I provided above. With Bucket Servlet, I showed you the SAL solution, but also you can do everything yourself, like to get the token, to add the field, to validate the token, and use the code which I provided in my presentation. Bamboo XWork, everything works out of the box. You don't need to do anything. You just add the XWork, and Atlassian will take care of everything of sending the CSRF token, generating CSRF token, sending it to the client, back from the client, validating it, just everything. Bamboo Servlet, again, you can, for example, get the token with the code I provided, then add the input type to the VM soy template, and then validate the token. So everything can be done by hand, or you can use SAL as usual. And Factory Servlet, all you need to do, you need just to add the requires XSRF check to the doPost method of Servlet. Here it is, for example, if we open here Factory CSRF attack and open our Servlet, you can see I just added to the post this annotation, and that's it. Everything will work. Factory will take care of everything itself, like to generate the token, to send it to the client, to send it back to the server. If you add this annotation, it will also validate it. That's it. That's how you can prevent it. So basically you've got a couple of choices. You can use SAL, you can use your custom solution, or you can kind of combine your custom solution with some classes which are available in different Atlassian applications. Bug Bounty is a program when, for example, you register your return for Bug Bounty, then independent resources can try your applications for security bugs. And then if a bug is found, you would need to pay for it. Here how much you pay, as you can see, there are different levels. For example, P1, P2, P3, and P4. Also, there is a level called P5, but you do not pay for P5. And let's talk where CSRF attacks are. So it's P2. If you've got application-wide vulnerability, then it will be P2, and you will have to pay $900. Other things, P5, it's, for example, if you forgot about CSRF attacks in the logout page, or for example, your serve token is not unique per request, or you've got problems in Flash based, so it's P5 and you don't have to pay for it. And other, you can see varies. Varies means that it depends on how much problems this attack gives to your application. And this one is negotiable with Atlassian and with the one who posted the bug. So that's it. That's all I wanted to tell you about CSRF attacks. Also, if you need some sample code, you can check my repo. That's all. Have a good day, and don't forget to prevent your application from CSRF attacks. Bye-bye.